Hello friends, welcome to YouTube channel GJ Civil Academy. Now we will look the chapter 1 part 2 simple stresses and strain. In last video we have seen now we will look for elastic limit. When a body is subjected by an external load, it goes under some deformation. And after removing the load, it will regain its original shape and size. This happens due to elasticity property. Okay. Now, when a body is subjected to external load, there is some capacity of that body that it will get after removing its load, it will get its original shape and size. But if you see that it is not actually means every body cannot go up to a certain limit, it will regain its original shape and size. But after some limit, it will not get, right? So that limit is known as elastic limit. Okay. So please be assured that what is elasticity and what is elastic limit. Elasticity is the property and elastic limit is the limiting force that up to which the body can regain its original shape and size. So this is the basic difference. Now what is modulus of elasticity or Young's modulus? Modulus of elasticity or Young's modulus is nothing but it is the ratio of tensile stress or compressive stress to the tensile strain or compressive strain. It is nothing but a constant that is denoted by E, and the unit of modulus of elasticity is Newton per mm square. Okay. Now what is modulus of rigidity or shear modulus? When the body is loaded within its elastic limit, the ratio of shear stress to shear strain is constant, and this constant is known as modulus of rigidity or shear modulus. It is denoted by G equals to tau. Tau stands for shear stress, okay, and divided by shear strain, that is denoted by phi. This one. So in the previous slide, if you see that E equals to stress upon strain, I have given that sigma upon E. So what happens that E has no unit, strain has no unit, so directly it becomes in Newton per mm square. What is the value of modulus of elasticity of mild steel? That is nothing but 2 into 10 to the power 5 MPa. That stands for Newton per mm square. Okay, for example that I am learning. Now, if you look this curve, this is nothing but a stress-strain relationship for a mild steel curve, ductile. It is a ductile material, mild steel. So, there are some A, B, C, D, E, F, 4 points. So, what is A? A is nothing but limit of proportionality. Okay, up to A point. This is a 0 point over here, 0. OA, or we can say that this point we will denote it as O. So this OA stands for elasticity, means it obeys Hooke's law, stress is directly proportional to strain. After that it starts some deviating, but still up to B point it follows the path, that is stress is directly proportional to strain, but up to B point the elasticity property will remain, the material will remain its original shape and size up to B point. Okay, after that the behavior is different. So C is the upper yield point. What is yielding? Yielding is nothing but going on rotating. The material is going to be rotate. Okay, so that is called yielding. So C is upper yield point. Okay, and then afterwards the mild steel material goes downwards. Okay, there is a decrease in stress but increase in strain. Okay, C to D. So that is nothing but the D is lower yield point. And after D point, what happens? The stress is going to be increased, as if you look get it. So stress is going to be increased, but not in proportionate with the strain. So after B, we cannot say that it obeys Hooke's law. Okay, it doesn't obeys Hooke's law. So E is the point where the material get ultimate strength. Means up to that point, the material can carry the load. But after E point, it is going to be breaking. Okay, so the F is the breaking point. That is stands for F, breaking strength. Okay. Now, this is the my steel bar. Okay, and it is subjected to P pull forces. Now, after gradually applying load on UTM, universal testing machine, so what happens that at some point at the internal, it is going to cross-sectional area is going to be decreased, and it forms cup or cone shape, and accordingly we need to decide whether it is tensile or compressive stress. Okay, so this can be understood by the practical association. Now here we comes for the next slide, that change in length due to axial load. So sigma is equals to P by A. Sigma stands for stress, P stands for load, A stands for cross-sectional area. So E is Young's modulus, stress by strain. So E is nothing but strain. So what is E? Change in length to the original length. Now if I want to form a relationship between E, I need to calculate the delta L value. So for that purpose, I will put a sigma value, that is P by A, and E stands for change in length to the original length. So P by A upon delta L by L. So it will become E equals to PL upon delta L by A. This one, yeah. Delta L equals to then PL upon A. Very simple. That is sigma is equals to P by A, stress upon cross-sectional area. E stands for Young's modulus, stress by strain, and strain value is for delta L by L. So E equals to sigma value P by A over here, E value delta L by L over here. So PL upon delta L into A, then this delta L becomes there, E here. So delta L is equals to PL upon A. Okay, I hope you have understood this concept. In the next video, I will take the problem. Thank you. If you like my video, please subscribe to this channel, GJ Civil Academy. Thank you so much.